Did that work? You know how my computer would always stop working during these Teams meetings? Between us stopping before Christmas and coming back yesterday, I hadn't rebooted my computer once. I just sent it to sleep. And since I came back and had to use Teams, I've rebooted it 4 times. And it's as slow as treacle. It did work like a champ, it just never stopped. Okay, because it's the first day back, because it's a new year,
and now for something completely different.
We are going to do something new. We're going to talk today about object-oriented programming. What you've seen so far, the fancy name for it is structured programming. Basically, do something else, do the next thing, repeat something, make a choice, do something else. So it's just one after the other. Object-oriented programming works in a different way. It thinks about things differently, and it thinks actually about things a bit more like we do. So for example, I'm looking at all these pictures coming up on my Teams, and I'm seeing a bunch of people. And I can assign attributes to those people. Black hair, brown hair, white hair, glasses, no glasses. Some people are vertical, some people are horizontal. So I can assign them different attributes, but they're all the same thing, they're all people. And that's what object-oriented programming tries to do. It tries to work from the basis that we can describe things and then get them to do things based on what they would do. Let me give you another example. There's loads of things around us. So we're going to think about the stuff in our program as things. And the fancy name for it is an object. We have objects all around us, and they have particular things we attach to them. So instead of people, we have dogs. And dogs have names and colours and breeds and how they are. Is it a happy dog? Is it a snappy dog? Is it a growly dog? Is it a psycho dog? And all of these dogs do the same sorts of things. They can all move. They can bark. They can eat. They can't all wag tails because they don't all have tails. So actually, that behaviour might need to be modified. But we can work our way through our objects and use those to describe what it is our software object does. So we can start making a model of the real world. So the dog that has a name and a colour and a breed and so on, in our object-oriented world, the object can have an attribute, and it's kind of like a variable. So the attribute is name, and we set the dog's name. Fred, Barney. We can set its colour, its breed, and so on. And we can make it do things. We can make it bark, we can make it eat, we can make it do whatever. Okay, so we can have an object that has things that describe it, and the fancy name for that's attributes, and it has things that it can do, and the fancy name for that is a method. And we can program these things. So we can set up our objects, we can attach attributes to them, and we can then make those objects do particular things. Now, it will only take you 10 seconds to think about how we actually use that in real life. Let me take that back. In our real life of making computer programs, anybody that's ever played a game, any of those tower defense games, all of those things that attack you aren't set up individually. They're all instances of something that attacks, a zombie that goes forward, a zombie that has an attribute of how many times it can get hit before it dies. And the different types of zombie can also be used to extend out. So we can have a zombie that walks, a zombie that wears armor, a zombie that's got a bucket on its head, whatever it happens to be. If you've ever posted on a notice board, there's a couple of things happening there where we use object-oriented. Everybody that is signed up to that notice board. So if you're signed up to Twitter or Facebook or Instagram or Snapchat or whatever it happens to be, every one of those users is an object and have an attribute. Their screen name, their picture. They have things that they can do, post, delete. So we use this all the time. And the idea is that we can reuse objects. The idea is we're trying to make it easier for ourselves when we program. So just look at that dog there. We've got an object called a dog, which has a name and a colour and a breed, and whether it's happy. It can bark and wag its tail and eat and fetch. What if we wanted to build another object called a cat? Well, do you know what would be really handy? If we could take the dog and just say, well, actually, based on what a dog is, we'll make another object called a cat, because cats also have names and colours and breeds and whether they're happy. They also can move their tails. It might not be wagging, but they can move them. They will eat. Not many cats fetch, and no cats bark. So what we can do is take the vast majority of this stuff, but change it. And we'll talk later about that. The fancy term is we can override the methods. So instead of the dog barking, the cat will meow. The good thing though is, once we have set all these up for a dog, if we want to set up a cat, everything that we've done for a dog works for a cat. We don't have to add anything. We can just rename it and say it's now a cat. And the fancy name is inherit. It'll take all the stuff that we've already done and reuse it. So we'll get to that in later weeks, but that's the idea of why we're doing this. If we can describe things, it means we can reuse them, which means we can program a lot faster. So how do we do it? In software, we need to put a couple of things in our Python program. We need to say what our object is. We need to store the attributes with it, and we need to assign some methods, things that that object can do. You're all very quiet. Has nobody got any questions? Normally you're jumping in by this time. You're all just falling asleep again.
It's all very elementary level stuff, you know.
Not
My
if you've
galaxy
never done
brain can
programming
understand this
before.
very easily.
It's not elementary if you've never done programming anymore. Remember, this is an introduction to programming class. Anyway.
I haven't done programming.
Okay, so we want to create a software model of that object. So, like I said, an attribute's kind of like a variable. So we want a set of data to store the attributes, and we want things it can do. So a method's kind of like a function. something that we can make that object do. So we can set it up in our software where we have the object with its attributes, which are kind of like variables, and things it can do, its methods, which are kind of like functions. And just so that we completely change every name, in our program in Python, we're going to call our object a class. And that comes from how we define real life. So all dogs are in the class Canis. They're canines. So all the different dogs all become canine. So that modeling has already been done by other people, so we're just stealing it. So we'll call it a class. So we can set up the class to describe what a dog is, and then we can set up lots of different dogs. And again, another new word, each new dog that we set up using that class is called an instance. So it's an instance of that class. So we set up how we want the dogs to look, and then we set up specific dogs. Let me try and show you what I mean. So we're going to say okay, so we're going to set up a class called a dog. And because it's Python, and because you love it so much, we're going to use some punctuation to show how things work. So in this particular case, it's going to be a colon. So the reason it's red underlined there is because I've missed my colon. So it's happy now that I've got my colon. You'll see it's indented, so everything I'm going to do now is belonging to class dog. I'm going to define my dog. I'm going to do that with a def. And you see, as I type that in, I've got a whole bunch of things that's come up, as usual, to give me some help. Your PyCharm will do exactly the same. One of the nice things we can define, so we can define a whole bunch of methods for our dog. But one of the basic things that we define is how we set up a dog in the first place, how we initialize our dog. So there's a particular way that we can initialize an instance of an object. So we use this in every object that we create if we want to. So we might want to set up an initialization method. And you'll see there, that's 2 underscores. And I've got a whole bunch of things that have come up. I'm going to choose init. And you see it's already chucked in a whole bunch of things for me. I'm going to get rid of them because we'll come back to them later. And I want to keep it simple just now. So we're going to initialize the object. Now there's a special keyword here called self. That just means whatever version of our object that we use. So when we set up each instance, it's going to apply to that particular instance. It's going to apply to itself. So in our particular case, we've got a dog, and it's going to apply to the dog that we send to this initialization method. So we can say something like self, and you can see there in the help, it knows that the self is the dog. So it's talking about this dog, and I'm going to say self dot, what do we have? Breed. Comes breed. It's a bit upset at that because it doesn't know what breed is. So like I said, a method's kind of like a function, and like a function, we can pass things to it. So when we initialize our dog, we can pass the breed that we want. Same as we would in a function. We can pass the color that we want, same as we would in a function. And once we've passed them, we can use them to initialize that instance of the dog. So we can say the dog has an attribute called color, and we're going to initialize it to be the color that we've passed in the method. Okay, so we've set up a class called the dog. We've defined a method called init. That's a built-in method that has a particular meaning for Python. And in the init method, we've set that particular breed to a breed that we've passed to that initialization, and we've set the color to the color that we've passed to that initialization. And then in our code, we can say things like, yeah, and that is short for initialize.
No, funny thing is you can actually spell it both ways. You can spell it with, like you can spell color with a U or without it. It works both ways. It's kind of funny.
It's the creeping Americanization of our language, sadly. It's color here and COLOR in America. Okay, so now that we have a class, now that we have a method, now that we've got some attributes that we have attached to that dog, we can set up a whole bunch of dogs using that setup. Anybody get any questions before we move on?
Yeah, Tony, can you explain please again the term self? Because like the breed and the color, it's the variables that we are passing through the method. What is the term self?
What is the
term self?
It just means that particular one. And I'm actually going to show you what that means just in a wee second.
Okay.
When I actually set up some instances of this class. So hopefully it will come a wee bit more, hopefully it will help just in the next 5 minutes or so. So if you just hold off in that, and if I haven't explained it by the end of that, come back in, okay?
Okay, thank you very much.
Thomas, 1, 2, and 3 is something that's automatically imported because I accidentally chose something from the drop-down list, and I didn't want it to, so I'm just getting rid of it again. I didn't even realize it, put it in there. I didn't notice. Okay, so that's the basic idea. Now I'm going to go back on to what you can see in your sorry, I was just reading Roland's comment, and Roland, sorry, it's incorrect. Actually, the main reason is because there was a divergence in English. So basically, a lot of people left the UK and went to America. And the spellings that were kept in America were basically the spellings that were used here centuries ago. The changes, so things like adding in the extra U to colour, were imports from French. So it was as the French moved in after some wars and a whole bunch of things. And our
Wait, so the
language changed.
American one is actually the original British one?
In essence, yeah, it's closer to the original one as it was centuries ago.
Then shouldn't you use the without the U?
Why?
Because
That's how we
you were like,
spell it.
oh,
Yeah.
Americanization and stuff, but
I'm
like
not
actually
American.
it's but it's not really American, it's actually English.
No, it's American now. It's American English now.
It was originally British though.
So?
Yeah, well, fine. You do you.
Okay, so that's how we do it. And what I'm going to do now is I've realised I've gone a wee bit off piste because your slides don't use the dog. So even though it's spoken about dog up till now, it's going to change its mind and start talking about something else. And it's going to start talking about cars. But it's the same idea. So I'm going to change dog to car. Instead of a breed, a car will have a make. Actually, I can still reuse colour because cars have a colour. So you see, I'm doing the same stuff. I'm putting in the same information. A car might have a registration number. So we can put that in the initialization as well. But to do that, we need to pass the registration. We need to tell it what it is. And if it's going to have a make, like Ford, it's probably going to have a model as well. So we've added in a few more attributes. We've got 4 attributes this time. But it's the same idea. Define the class, give it a name, and now we are going to put in an initialization method called init. Now remember, we could add in more methods. I could add in a method called
Mr. Colon there.
So I could add in a method that said, let's update the car's odometer. So the odometer is the thing on the screen that shows how many miles a car's done. So I've made a new attribute called distance travelled. And I've set a method that said when the car moves, I want to update the odometer, and I have to tell it how far it's gone. Use that to update the odometer to how far it's travelled.
Do you not need to feed distance traveled into the thing as well?
Distance travelled is an attribute of car. So it's, I've now called it self.distance travelled, so it's now an attribute that the car has. So we've added in another attribute. And all I've done is set up a method to change that attribute by saying how far it's travelled. I could put other things in there saying it's new location and the time to service. So self dot miles to service becomes self dot miles to service minus how far. So if this car needs serviced every 8,000 miles, we take off how far it's travelled, and that then gives us a new value for when it needs serviced. Okay, so we can add in a whole pile of these. Okay, so we can def or define a method. Abayomi. Shellcode, yeah, normally there would be underscores in there. That was just me being fast, because apart from anything else, I'm actually just going to delete this bit. Nice and simple. Nope, we're in class car. I changed it because what I said was I've gone off piste because your slides actually start talking about not a dog. It jumps from a dog in the slides to a car. And if you want to know why, you're going to need to ask Jerry. They're all let out. Oh my goodness. Okay, so we can define a class. Sorry, we can declare a class, give it a name, and then we can define methods that go along with the class. And there's a built-in Python one called underscore underscore init underscore underscore that will let you set up each instance of the class. And I realize me saying that doesn't really mean anything. So instead, what I'll do is I'll set up some instances of the class. And you're right, it was called dog and then we changed it to car, Roland. So we've defined what our car is, and then we can set up some cars. So my car becomes, so it's just like setting up a variable. We give the instance a name. In this case, it's my car. I bought myself a new trackball because my shoulder was getting sore using my mouse up here. And I appear to have, there we go. I managed to batter it off the desk there and make it link to a different computer. Okay, so we set up our instance of the class. In this case, we're calling it my car. Python at the moment doesn't care. I could say my car becomes 1 and Python would be happy. So it's just like a variable. Yeah. For Python to know that I don't mean it to be that kind of variable, I mean it to be an instance of a method, I need to say what it is. And in this particular case, the way we do that is we say it's going to be a car. And you see there that my helpful IDE has told me, oh yeah, you've got a car and that's a class. Fantastic. And to set that up, you're going to need to have some stuff. It's even kindly reminded me what that stuff is. A make, a model, color, registration. So I'm going to set that up. I've now realised I don't know a single Porsche model. Somebody help.
911.
Okay, so now I have a new instance of the car. You'll have a similar thing in PyCharm, it will pop up too. So the same sort of things that popped up, you'll get help in there as well.
Yeah, we do it. As soon as you put the brackets in, it does the same thing.
Okay, so we now have a car. Hopefully that helps on the self thing. So I've called this method to initialize my car. So when we call that, what it means is it's talking about the one that we've sent it, in this case, my car. So it means my car dot make, my car dot model, my car dot color. It's itself. We're changing itself. And if I want to change a different one, I can do something similar. So this time, when we initialize it, the self that it's talking about is Nicholas' car. So it just means the one that we are passing to it. Does that make sense now, Paraskevas?
Yeah.
Okay. And we can keep going. We can start doing lots of cars. Each one being an instance of the car method, each one having its own attributes that go along with it, but each following the same basic layout and having the same attributes and methods. Even cars that don't yet exist. Okay, so we can run through and we can set up lots of instances, but they all take the same basic setup. Everyone happy with that?
I'm good with it.
Okay. So we define a class, we can have a special method that initializes it. Once we've done that, we can make lots of different cars using the same initialization and setting them up with different names, and that's multiple instances. Okay, that's all we're going to do this week, because it's just a gentle introduction. We're just coming back, it's first week back, so it's just a nice easy one. So all I want you to do in the lab is to use the same kind of idea, but what I want you to do is create a class that's a student. It will have those specific attributes, and I want you to set up some instances of that class. Questions?
I guess the questions will come next lecture, right? Like once we actually tried this.
Shushed. Yeah, I think so. As I say, this is just a gentle welcome back lecture to get you back into the swing of things. It's not exactly taxing, I don't think anyway. Roland, no, you don't have to submit your program. Not this week, I think it's too easy, but of course we'll be in the lab, and if you have any problems setting this up, just give us a shout. But I don't think it's even worth setting up an assignment in Teams. I think it's so easy after our first 3 months.
I mean, if you follow along in the lecture, you literally just have to change some attributes and that's it.
Yeah, you pretty much do exactly what I just did in the lecture. Any other questions? Pablo says he's available for questions. They do have to be Mac related, so you always have to ask them from a Mac. If I am creating a program on the Mac, how will I do this? Okay, you always have to ask them like that, or he'll just ignore you. How does a lab class operate? Same as it always has. So I'm going to finish up this lecture shortly. Once the questions are finished, we'll take a wee break, and then we'll all be in the lab, which is just a big Teams meeting at 11 o'clock. Myself, Pablo, and Enrique will be there if you need some help. So just the same way it worked in term 1. The slight difference this term is, and I'm beginning to realise how many people haven't bothered reading the announcements in Teams. So your timetable says that we have a lecture at 9 and then a 2-hour lab. I'm changing it this term because I'm conscious that some people work on it during the week and don't quite get to an end. So what we're going to do, we're still going to have the same 3 hours. So it's the same 3 hours on your timetable. But what we're going to do is, so today we've had a 10 o'clock lecture. So lecture 10 till 11, assuming I don't ramble on. We'll then have a lab 11 till 12 on this week's lecture. And then next week's lecture, we will start at 9 next week, but the lab will be on this week's stuff. So I can't imagine anybody will struggle with this week's one, but if you do, if you come back next week, you can ask us for help. And what it means is, hopefully, everybody will have completed everything before we move on to the next bit. Because I was a wee bit conscious last term that not everybody finished everything, and as you know, everything builds on everything else. So I'm changing it to try and give you that opportunity to come back and ask questions for anything you couldn't quite get. So we'll give that a go and we'll see how it works. Sound okay?
All good with me.
Okay, Abayomi, has that answered your question? Right. Okay, in that case, I will stop the recording.